So if I had a curve, and if I wanted to find the arc length of this arbitrary curve, then we know that the arc length formula is the integral from a to b of the square root of 1 plus derivative of y with respect to x squared. But how is this formula actually derived? We know that we can take an approximation by using straight lines. So let's draw another curve. We can take an approximation of this curve by using straight lines. Okay. And the x component for these lines is going to be delta x. So let's call these lines line 1, line 2, line 3, and so on. We can approximate the arc length by taking the sum of all of these lines from I equals 1 to n of L sub I. And as n gets larger and larger, the better and better the approximation is going to be, because you're going to be using more and more lines to approximate the arc length. So let's think about what L sub I is equal to. Pretty straightforward. You just use the distance formula. So L sub I is going to equal the square root of, say, x sub I plus 1 minus x sub I squared plus y sub I plus 1 minus y sub I squared. Okay, so we can simplify this by using the mean value theorem. So if I have f prime of x, the derivative of y at x, then that is going to equal some interval. Let's call that interval x sub I plus 1 and x sub I. So it's going to equal the slope between those 2 points. So we can move this over to the left side. So equal to, let's just call this y sub I and y sub I plus 1. So y sub I plus 1 minus y sub I. So we can substitute f prime of x times x sub I plus 1 minus x sub I into y sub I plus 1 minus y sub I. And so when we do that, we get the length of each line is equal to the square root of x sub I plus 1 minus x sub I is going to be delta x. So let's just say that's delta x squared plus f prime of x times delta x, all of that squared. Okay, so what we can do is we can factor out a delta x. We can factor out delta x squared. So that becomes the square root of delta x squared times 1 plus f prime of x squared. And so that is equal to the square root of 1 plus f prime of x squared times delta x. When we take the sum again, the arc length is approximately the sum from I equals 1 to n of the square root of 1 plus f prime of x squared times delta x. Okay, so now as the magnitude of delta approaches 0, or as n approaches infinity, you're going to get the exact arc length. So the exact arc length is equal to the limit as n approaches infinity of the sum from I equals 1 to n of the square root of 1 plus f prime of x squared times delta x. Now, what does that become? I mean, what is an integral? An integral is just an infinite sum. So this is just an integral. So the arc length is the integral from a to b of the square root of 1 plus f prime of x squared.